Hey everyone, so I just want to work through some of the free response questions. So these questions are coming from 2019, and it's the set one free response questions. As far as I know, this is the only year where they had two different sets. So we'll scroll down. It's got the reference table on hand. You'll notice it's very similar to the AP Physics 1 with some slight changes. Obviously, we're going to ignore the electricity and magnetism section. So this is the first question. Now, I highly recommend that you go to the website. I'll have a link in the description below. You can go there, try to work on this yourself, and then compare your answers. All right. So looking through this, this is a question where it's got some fluid stuff. Now, we don't actually need to know too much fluid stuff in order to answer this question. So if I scroll down to part A, it says, does the speed of the object increase, decrease, or remain the same? So let's see the scenario. So we have an object being dropped into a container of fluid, and then they have this graph for the speed data, which they're getting through a motion tracker, so through a video analysis motion tracker. Obviously, this is an extremely easy question. They want to know is what's going on with the speed. Well, according to the graph, it's increasing. So my answer to this would be increasing. Now, this actually is a 1 point question. Right? This is a 1 point question. There was really nothing else that you need to do for here. So the second part says, in a brief description, describe the direction of the object's acceleration and how the magnitude of this acceleration changed as the object fell. All right. So if I'm looking at this, as the object is falling in the container, since the velocity is still increasing, we know that the acceleration has to be in the same direction as the object's velocity. So since the ball, what is this, rock? The rock is falling downward, then we know that the acceleration also has to be downward. So acceleration is down. And then they want us to talk about how is the magnitude changing. Now, if the acceleration was constant, then the velocity would be linear. That's my best linear line. So it would look something like this. Since the velocity is increasing at a slower rate as we go on, the increase here is a lot sharper than the increase over here. So I can tell that my acceleration should be decreasing over time. It's starting at some value over here, and it's starting to look like it's going to zero. So it's down, and then it's going to be decreasing. Now, if I'm looking over here, it says that this is a 2 point question, and 1 point was given for just stating that the acceleration was downwards and that the magnitude was decreasing. So basically, a good example of a statement that you could say was, because the object is moving downwards and speeding up, the acceleration must be downwards. Because the slope of the graph of speed as a function of time is decreasing, the magnitude must be decreasing. So it's the two things that I said before. Now on to part three. It says, using the graph, calculate the approximate value for the magnitude of the acceleration of the object at 0.2 seconds. All right, so this is 0.2 seconds. They want the approximate magnitude of the acceleration. Realistically, what we're going to end up trying to do, we'll have to kind of draw a line that's tangent to the curve. So actually, that's a pretty good tangent line. What we're going to want to do is do a line and then pretty much do a slope of that line. You don't really want to pick any points, data points that they're using, because any two that I choose, it'll be slightly off. So what we're going to end up doing is just finding 2 points on here. So let's see. I did not. Okay, so this will be a point right down here. And then another point could be, I guess, that point. Doesn't really matter as long as it kind of makes sense with what I'm doing. So let's see. The points would be 0.8 because it would be slope is equal to change in y over change in x. So 0.8 minus 0.555. These are meters per second. And then I could divide it by the x values. So this is going to be a little bit trickier. So this is about all right, so each one of these little lines is going to be 0.01. So that's going to be 0.23. 0.23. And over here, that's going to be 0.11. This is going to be in seconds. So if I plug this into my calculator, 0.8 minus 0.55 divided by 0.23 minus 0.11, I end up getting 2.08 meters per second squared. Now, this question was worth 2 points as well. They basically said that you can, that is exactly what I said, draw a trend line through the point as best you can. Pick 2 points on that line, take the slope of it, and you'll end up getting your answer. They said that they got an acceleration of about 2.22, but my answer of 2.08 is pretty close enough that you would end up getting a point. Don't forget if you do end up using the answer key, just realize that there is leeway as far as the idea being, are you actually doing the correct physics? So if you did the process of drawing a trend line and you did attempt a slope, the graders are going to be aware of that and they'll give you points to fit that. All right. So now they give us this equation. They say this is our velocity and they want us to figure out the vertical displacement for part 1, and then for part 2 they want us to find the net force. So this is actually one of those questions where you're going to end up having to use a little bit of calculus. I know I mentioned before that the chance of you having to do an integral or derivative using an e function is on the rare end, and that is kind of true. This actually isn't really a very common question. I'll tell you now that this is a 3-point question. So if you weren't really too sure of what to do, as long as you attempted something, you might be able to get a point, but you also don't need the full points to do well on the AP. So let's go through this. For this first part, actually I should correct that. Each part is going to be 3 points. So this is actually worth a full 6 points in total. Okay, so for this first part, they want the vertical displacement. So they give us a velocity. That means I have to take the integral of this. As I mentioned, you can kind of like think back to what the equation is. If I had velocity and I wanted position, I would just do velocity times time. So this means that I just do a integral of my velocity equation with respect to time. And I'll end up getting my displacement. So if I do this, so we're going to take the integral of a 1 minus e to the negative bt, all with respect to time. And we're going to do this from 0 to t. Because they want us as a function in time, and they don't really give us any initial values, or at least we can figure out what the initial values are. So what we're going to end up doing, the a actually can be pulled out. So I'm going to do that now. I'm going to just get rid of the a and pull it out of here. So now I have to integrate this. An easy way to change this up, you can actually split this into 2 parts. So you're doing the integral of 1 dt from 0 to t minus the integral of e to the negative bt with respect to t from 0 to t. Now it can get a little confusing to keep track of all the t's since we have, this t here and then we have all these t's here. So you might actually want to put a little tick mark to show that these times aren't the same as these times, or at least not right now. Like while we're doing the math, they'll become those times. So continuing on, the integral of 1 is pretty easy. It's just, attach a t to it. So my a stays there. This turns into a t. I could put a little tick mark there. And then this one, so you can look at the reference table for the rules on this. But essentially what it is that you're going to divide the coefficients. It's actually very similar to the quadratics. You're going to divide the coefficient by the derivative of the exponent. So it would be negative b, and then the e to the negative b t stays there. And this is going to be evaluated between t, or 0 and t. I apologize for the fact that I don't really have a whole lot of room. So from here, I can now plug in t and 0. So I get a times t. Since I have minus and then I have a negative down here, that becomes plus 1 over b e to the negative bt. And this is going to be minus, and now I'm going to plug a 0 into all these terms. So minus 0. It's going to become plus, so that's actually going to be another minus. Distributing the negative over, minus 1 over b e to the 0. This is going to simplify. Really don't want to use that. Let me put the work up here. So that's going to become x a times t plus 1 over b e to the negative b t, and then e to the 0 is going to simplify down to 1. So that'd be minus 1. But I still have the negative b there. From here, what I can do is I could just actually plug in the numbers. Actually, I'm going to get rid of this one since I don't need it. I'm going to plug in the numbers now. So this just becomes 1.18 times t plus 1 over 5 e to the negative 5t minus 1 over 5. There's a few things that you could do to try to clean this up, but that's pretty much where you can end it there. This was a 3-point question. So there was 1 point just for mentioning that you had to take an integral. So even if you didn't know how to do the integral of an e function, it doesn't matter. You could just do the integral anyway, or just say that you're going to do an integral, and then just attempt it. The second point was actually doing the integration correctly. So for stating these bounds going from 0 to t, and then doing the integral to essentially get to this point right here, where you start plugging the numbers in. And then you got the third point was for plugging the numbers into whatever you got. So there's a good chance that you probably could have gotten at least 2 points even if you messed up your integration. So even if you don't really know what you're supposed to do, at least try something, and you might get partial credit. Like I said, you would have gotten at least 1 point just for stating that you had to do an integral. All right, so for part 2, now they want us to figure out the force acting on the object. So I'm actually going to do this in a different color just so that it kind of splits it up. So if you think about it, how are we going to get force from velocity? Well, the easiest link between the two is acceleration. So if I can use this velocity to find acceleration, then that acceleration can be used to find force. Now this is going to be a little bit easier. Integrals are always a little bit more tricky. So to find the acceleration, remember that's velocity divided by time. So that's a derivative. So that's going to be the derivative with respect to time of this equation a times 1 minus e to the negative bt yada 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 business. So the 1 actually goes away because when we end up splitting it up, we'll end up having the derivative of a minus the derivative of a times this e function. So really, I'm only going to focus on this. So this actually just simplifies to be the derivative with respect to time of a minus a e to the negative b t. As I mentioned, the e function is actually extremely similar to the polynomial derivative. So what we're going to do is take the exponent, multiply the coefficient by it. So this is going to get me negative a times the exponent. When I take the derivative of that, that's just going to be negative b. The only difference is that I don't subtract anything from the e function. So in the polynomial, if you remember, I always had to subtract 1 from the exponent so that the number always went down. In this case, I don't do anything. It's just move it over, multiply, and that's it. So it's a little bit simpler than the polynomial one. So cleaning this up, this just ends up becoming a b e to the negative bt. And then what I can do is say that, well, I know that force is going to be mass times this acceleration. The mass in this case, if I scroll up, the mass is 12 grams. I'm going to want to convert that. That's kind of a dirty mass. 0.1, 0.0, it's 0, 0.2 times the acceleration. So it's going to be 1.18 times 5 e to the negative 5t. So plugging this all in, 0.012 times 1.18 times 5 gets me 0.071 e to the negative 5t. So this would be my final answer. Now, once again, I said that this was another 3-point question. So you got 1 point, again, just for stating that you're going to do a derivative. So basically, you got 1 point for stating this line. You got 1 point for getting to this equation. So where is it? Here. You got 1 point for this. And then you got another point for basically saying that whatever acceleration you got, you multiply it by mass, and you get this. So this is the 3rd point. Now this one's actually a lot easier to get the points for because once again, if you just stated that you had a derivative, that right there is a point. But what they are telling you is that this answer isn't worth 2 points like it was up here. It's actually only worth 1 point, meaning that if you completely botched this derivative, let's say you completely didn't know what you're going to do and you just kind of made up an answer. You just said, oh, I don't know, the acceleration something like, keeping the numbers correct. Let's say you said it was a squared minus e bt divided by, I don't know, some garbage like this. Well, what this means is that if you just realize that you had to then multiply this answer that you got by m, then you would get the 2nd point. So between these two, even if you have no idea what you're actually doing and instead only remember that, taking, whether to do an integral or derivative, but not really knowing how to do it, you could get half of the points without actually doing the calculus. This is why I keep mentioning that even though this test requires calculus and um, the calculus can be difficult at times, you don't really need to stress too much about it. All right. So now we have to get to part C, and great, it's actually kind of blocked out. So they want us to figure out uh, the constant speed of the object, um, and they said that this ends up being filled so that it actually does end up reaching this constant speed term. So there is a few ways to actually do this. Um, let's see. Okay, so if we actually looked at this equation, v equals a 1 minus e to the negative bt, what I know is that this equation, or this part in particular, is going to zero. That's actually why it's curving like that. So this term, as t goes up, so as t increases, this e term becomes zero. So e to the negative bt becomes zero. Because of that, this will eventually become a times 1 minus 0, which is just equal to a. So we can actually say that the constant speed term is going to be equal to a. Um, and essentially, you could say a variety of different things. Is say that as t goes to infinity, e to the negative bt goes to 0, which means that this equation becomes a. So you could pretty much say that. Now, they actually said that you could get credit if you solve this mathematically. So again, there are a bunch of different ways that you could do it. This was the easiest one. This was actually worth 2 points. 1 point for stating that it was going to be equal to a, and 1 point for the explanation. I don't think you would get any points if you got this first part wrong, though. So you would need to make sure that you would have the entire thing. So if you're doing a self-grading right now, just be aware of that if you did not say v equals a, but you said something similar to what I said, it doesn't matter. It doesn't count. So then part 2 says, what is the force exerted by the fluid on the object at this time? So they want the force exerted by the fluid. Honestly, I guess you could probably get around. No, I don't think you would be able to use this equation. I think the easiest one, I was trying to see if there was a calculus version way of doing this. None that I feel would be easy. I think the easiest would be to go back to basics. We have the force of gravity pulling it down. We have this fluid force, which I'm going to call F fluid, pulling up. Since it's moving at a constant speed, we know that it's in equilibrium, so the net force is going to be equal to 0, which means that the force from the fluid is going to be equal to the force due to gravity, which is equal to mg, which is equal to 0.012 times 10. So we can already figure out that this, wrong subscript, fluid force is going to be equal to 0.12 newtons. This was a 2-point question as well, and it said that you basically need to, you got 1 point if you made a comment about how the net force is being equal to 0. Whenever it's moving at a constant speed, you probably make that whole comment. It probably would help to mention that it's due to Newton's first law. And then basically saying this, saying that this means that these two forces have to be equal, therefore the fluid force is 0.12. And that was pretty much it for this first question. I'll go through the other questions. So if you have any other questions, feel free to let me know. Otherwise, good luck and have a great day.